This begins part 2 of our weekly review. This part includes graphing and measurements, so things like density, also the metric system. Alright, so first things first, when graphing, you need to know that your x-axis is located on the horizontal, the y-axis is the vertical axis. And always, always, always on our x-axis we have our independent variable. Always, always, always on our y-axis we have our dependent variable. Okay, so you can see here, here's our independent variable, number of cars washed, and then the dependent variable is the amount of money that they raised per their cars being washed. And you can also see it's set up how I like a graph to be set up. They have titles for things. So here's the title of the axis, title of the axis, title of the graph. It actually could be much more specific. It should be more specific. And then they should probably also connect the dots to make a nice little line graph. Alright, so yay, something kind of different. We have graphical relationships. So a direct relationship, as one increases, the other increases, and the graph will look like this. So as one variable increases, the other one increases, the graph looks positive. An indirect relationship, as one variable increases, the other decreases. So that will produce that negative slope right there. Okay, a cyclic relationship is where one variable increases, the other changes in a predictable pattern. So things like the tides, right? So as the day goes on, you have a low tide and you have a high tide, and then you have a low tide, then you have a high tide, then you have a low tide. So that's a cyclical pattern. All right, and then having no relationship is where one variable increases, the other stays exactly the same. So that's what you get. You get a straight line. If we were going to put these graphical relationships into words, you see here that this graph shows us that it's showing us relief on the x-axis, that's our independent variable, and the average rate of erosion. And if you remember, relief is the highest minus the lowest elevation on a map. So as the relief increases, okay, the average rate of erosion also increases. So that would be called what kind of relationship? Right, a direct, because as one increases, the other one also increases. So our other graphical representation we have here is between relative humidity and air temperature. And you can see it's over the course of a day. So we have midnight to midnight. So we have air temperature over here, relative humidity over here. So as relative humidity increases, air temperature decreases, or as air temperature increases, relative humidity decreases. So they are not direct now, they're indirect. Because as one increases, the other one decreases. Oh, good stuff right here. Measurements, okay, and the common instrument in which we use to take those measurements. So volume of a regular object, we're going to use a ruler, remember, because if you remember the formula for volume, length times width times height, we can use a regular old metric ruler. Volume of an irregularly shaped object, like when we did our Lego, or you can see here that they have a ring or a piece of chalk. You're using the graduated cylinder to measure the change or the water displacement. So that would be, your units would then be in milliliters here, whereas with length times width times height, they'd be in centimeters cubed. All right, to find out mass, we use a scale or a triple beam balance. For distance, we can again use a ruler times stopwatch. So huge, huge, huge thing that is actually often overlooked is an average. To find an average, which is also the mean, right? So an average is the sum of all the numbers divided by how many numbers you had. So for instance here, right, we add up all these numbers and we get 32. And then we divide by how many numbers we added. So it's 1, 2, 3, 4, 5, 6, 7. So then you divide 32 by 7, you get 4.57, and that is the average. You must know how to do that. You must remember that formula. Alright, so this little data table or chart over here should look familiar. Right? Remember, it was on our notes. So for mass, it's the matter inside an object. It's given the unit of grams. Length, how long or far. Meters, volume, the amount of space an object takes up. That can be liters, milliliters, cubic centimeters, and then look again here, it's so important, it's on there twice. The formula for volume. Density is how compact an object is. Formula for density is also super important. Mass over volume. Alright, then you guys know temperature. So over here, we're just looking at finding volume using a ruler. So you measure length times width times height to get the volume. Okay, and then I've got a couple of, I like them, cool pictures that show density. So this map shows population density, so you can see the most populated areas are the darkest ones. So those are compact with people. Okay, now this picture right here, this diagram kind of shows us the density of common liquids. Now where we have, see, the greatest density at the bottom, the least density at the top. So we have light corn syrup at the bottom. It sinks to the bottom. You could pour all these in here at the same time and they would eventually separate out because of their densities. So if something is sitting on top of something else, that means it is less dense. So the least dense liquid is isopropyl alcohol and the most dense liquid is light corn syrup. And last but certainly not least is the metric system. It's also referred to as the SI units, SI system, International System of Units, something along those lines. Okay, so you can see here, this was the jingle, well, except for the unhappily part, but King Henry died, I say Monday, drinking chocolate milk. So that's how you remember, and that's the most important part of the metric system is the order that it goes in. Because each of those letters stands for one of the metric units. So kilo, hecto, deca, the base unit, meters, grams, liters, deci, centi, and then milli is your smallest unit. So remember, like the stairs, depending on which way you're going. So if you're converting from centi to kilo, then that's going 1, 2, 3, 4, 5 places to the left. So you're going to move your decimal point. Let's say your number was 56. Here's your decimal point. You're going to move it 5 places to the left. 1, 2, 3, 4, 5. 2, 3. So 56 centimeters equals 0.00056 kilometers. Remember, it's exactly the opposite if you go the other way. So let's say we're going from meters to milli. So, and our number is going to be, I'll use a different color. Number is 1.5. So here we go. 1, 2, 3. So we're going 3 places to the right. So we move our decimal point 1, 2, 3 places to the right. So now we have 1,500. So 1.5 meters equals 1,500 millimeters. So just remember when you're doing the stair or moving your numbers, you don't count the stair that you're on, you just count the physical movement from one to the next. 1, 2, 3. Get it? Got it? Good.